Hi, my name is Kristen Henderson, and today I'm going to tell you about a framework for scoring emerging brands in the consumer packaged goods space. Distributors, brokers, and retailers need to decide which emerging brands they'd like to invest in. Some of these new brands will grow rapidly, others will fail, and many fall somewhere in between. But our ultimate goal is to learn to tell them apart as early as possible. We'd like to start with an emerging brand with limited history and an uncertain trajectory. Apply a decision framework using multi-criteria scoring and statistical benchmarks, and generate predicted opportunity tiers for each of these brands. Prior work is focused primarily on demand forecasting, and our approach is to use not just sales predictions, but to evaluate brands based on multiple performance signals. The data were 5 years of weekly retail sales data. There were 22,500 brand extensions across 8,700 brand families. The brand hierarchy goes from brand owner to family to extension to UPC. So you can think of this like the brand owner is Coca-Cola Corporation, the family Coke, the extension Cherry Coke, and the UPC 12-ounce can. Our primary variables were case and dollar sales and percent ACV, which stands for all commodity volume. Percent ACV is a weighted distribution metric, which essentially tells you how much of the market the product has access to. So a brand that's present in more stores and larger stores has a higher proportion of total market volume or higher percent ACV. The data set didn't have outcome labels, so I had to create those. I did this by selecting a single product subcategory, and I focused on brand families with a single brand extension so that the brand family and extension performance would be identical. I then plotted trajectories of sales and distribution and used that to hand label 112 brands across 4 performance tiers. To show you what brand performance looks like, here I plot distribution coverage or percent ACV. And I'm going to show you 4 real examples from the data, one from each tier. So this blue brand is a stable brand. Here I'm showing you a brand that grows rapidly over the past 2 years. In orange, a steadily declining brand. And in red, a discontinued brand where ACV collapses to near zero and never recovers. I start with raw weekly case sales over the past 5 years, and from this I compute year-over-year growth for each brand's most recent 52 weeks. Using this year-over-year growth, I extracted 3 demand momentum features. Level is the median in the growth, acceleration the trend of the growth, and volatility is the spread of the growth. I then built a scoring framework to help brokers make this decision using a technique called multi-criteria decision analysis, which evaluates brands across multiple criteria using a weighted sum. So from this, I generate a single opportunity score, and ultimately I'd like to use 4 criteria: demand, distribution, promotion, and category context. But for this project, I focused just on demand, and that's a composite of the 3 features I just showed you: level, how fast the brand is growing; acceleration, is that growth speeding up or slowing down; and volatility, how consistent is that growth? And some weighted combination of these 3 forms the feature demand momentum. So I tested multiple feature and weight combinations and asked which one of these gives the biggest separation between the tiers. The higher the gap between the mean of each tier, the better. So I started with just using the feature level, and this separated out the growing and stable brands very well. But at the bottom, the orange and red dot, it failed to separate out the declining and discontinued brands. So if we look in this middle column, I added volatility to level, and the separation between the declining and discontinued brands jumped up without losing too much separation at the top. Adding acceleration failed to widen any of the gaps, and so I moved forward with level and volatility, providing the most balanced configuration and the widest spread between the tiers. I then benchmarked the MCDA framework with two statistical models. Each one answered a different question. So I started with the logistic regression model, which answered whether the brand is a low-performing brand or a viable brand that's worth investing in. And the best configuration of this model used both level and volatility and resulted in an 83% balance accuracy. I also used an ordinal logistic regression model, which classifies observations into ordered categories. So instead of a binary classification, this model can tell us which of the 4 tiers a brand is predicted to be in. And the best configuration of this model used level by itself and achieved a lower balance accuracy of 58%, but it achieved an adjacent accuracy of 92%, which says that when the model gets the tier wrong, it only does so usually by 1 tier. This matrix shows us how many brands were classified correctly in green and how many were misclassified in red. So the logistic regression model misclassified 19 of the 112 brands. The ordinal model, the yellow cells are off by 1 tier and the red off by more than 1. So this indicates that the ordinal model struggled to classify discontinued brands. Ultimately, we want to predict brand outcomes in advance. So I truncated the data 6, 12, and 18 months prior to the latest observation and looked at how the models perform. I started with the MCDA model, and using all the data, this model got an 83% balance accuracy. 6 months out, it lost a percentage point to 82%, but 1.5 years out, it lost 11 percentage points and scored only 72% balanced accuracy. The logistic regression model, on the other hand, also started at 83% balanced accuracy with all the data, but it stayed stable, nearly dropping only 1 percentage point over the full 18 months. The ordinal model started at a lower balanced accuracy, but it also was quite stable over time. So then I wanted to look to see how the models that I built with my hand-labeled data set, I wanted to validate that against 18 brands that the stakeholder provided that were either acquired brands or brands that had declared bankruptcy. So here I'm showing you 4 hand-labeled brands, 1 from each of the tiers, and their MCDA scores 6 months out. In white, these are the acquired brands, and the gray rows are bankrupt brands. And so the acquired brands have score high MCDA scores, and the bankrupt brands score low on the MCDA scores. And this is exactly what we'd expect. For the ordinal model, 6 months out, the acquired brands also are ranked into higher tiers, and the bankrupt brands, the ordinal model correctly places them at the bottom. For the logistic regression model, the acquired brands that have high MCDA scores, the logistic regression model performs well with these. Similarly, with a bankrupt brand that has the lowest MCDA score, the model correctly classifies this, but it struggles with brands that score somewhere in the middle. So what I've told you today is that a simple demand feature, median year-over-year growth, can be used to distinguish low-performing from viable brands. This framework is forward-looking, and prediction accuracy is stable even 18 months out. And this is a proof of concept that the MCDA framework has been validated by statistical models and is designed to be expanded as we add new criteria. Thank you very much for your time. Please connect with me, and I'm happy to take questions.